Hey, welcome. Today we're going to be talking about what a mole is and how to convert between moles and atoms or molecules, or back from atoms and molecules to moles. And this is a huge topic in chemistry. Alright, so the first thing I want to say about it is we don't mean a mole like a small mammal that digs or whatever. That's what we mean in our everyday speech, but this is going to be a little bit different. Thinking about a mole, it's a unit of measurement. It's kind of like a dozen. So you could say you have a dozen of eggs, or a dozen of just anything really, like a dozen shoes or whatever. And a mole is pretty similar in the sense that you can have a mole of anything. We typically have moles of atoms of a certain type or molecules of a certain type, but you theoretically could have moles of eggs or moles of shoes or whatever, in the same way that you can have a dozen of whatever you want. And so I'm going to use this idea of a dozen to teach by analogy. So I'll teach you with something that's quite easy, working with, say, dozens, and use those concepts to bridge over to something that's a little bit more involved, and that's of a mole. So first of all, if we were going to work with this problem here, 1.5 dozen eggs is equal to how many eggs? So you probably know how to do this in your head already, but I want you to think about why you can do this. I run into students who sometimes they know what to do, they know what the algorithm is, but they don't really know why they can do what they can do. So first of all, we can think of this as an equivalency. 1 dozen eggs is equal to 12 eggs. That's our equivalency, meaning you can set these two things equal to each other. And as long as we have an equivalency, we can do conversions. We can convert from one thing into another. So if I were to take this equivalency right here, divide both sides by 1 dozen eggs, algebraically speaking, this left side will cancel out and be equal to 1. And the significance of that is, remember, if you take 3 times 1, you end up with 3. 5 times 1, you end up with 5. So essentially anything times 1 is itself. That's the identity property of algebra. We can exploit this by taking our given information right here, 1.5 dozen eggs, multiplying it by a fraction that we have proven is equal to 1, and we end up with the same amount of stuff. It's just counted in a different way. So 1.5 dozen eggs is exactly the same as 18 eggs. It's just being counted in a different way, using different units. We're going to use the exact same concepts moving forward. Alright, so let's do nearly the same problem. So 1.5 moles of chlorine atoms is equal to how many chlorine atoms? Well, similar to what we just went through, we're going to write our equivalency. And here's where things get a little bit different. 1 mole of anything is equal to this astronomically large number, 6.02 times 10 to the 23, of that thing, and the number is just so large because atoms are just so incredibly small that to count a meaningful amount of atoms in a given volume or a given mass, you have to count a lot of them. So this is just astronomically large, and so try to remember that number if you can, because that's going to be really important all throughout chemistry. So in the same way I did the previous problem, we're going to convert moles of chlorine atoms into atoms. And if we know our equivalency, we can set it up just like we did the previous problem. We do the math and it turns out to be this as our answer. So we could say, just as a recap, 1 mole of anything is equal to 6.02 times 10 to the 23 of those things, Avogadro's number, and we can use that as our equivalency to do conversions, dimensional analysis. Let's try the opposite way, moving from atoms or molecules into moles. So first of all, this is our given information here. So how much is 7.89 times 10 to the 24 atoms of chlorine into moles of CO? Well, remembering our equivalency here, we can do a similar problem. We need to have atoms of chlorine in the denominator to be able to cancel out our given units of atoms of chlorine. So we can set up this conversion, this dimensional analysis right here, given that we know this equivalency, and we end up with our answer. And that's all there is to it. So reviewing what we've done, you can go back and forth in between the number of atoms or molecules, or really anything, into moles in one direction or another. And that's what we just talked about here. My next lesson I'm going to do is going to be converting from moles into mass, and so that part 2 is coming up right now. You should see a link in the upper right. If you have any comments down below, please let me know, and I hope you all have a great day. Take care.